A very good morning, good afternoon, and good evening to all the participants, candidates, and my friends who are taking this NPTEL MOOC course, title of which is Application of Forecasting, Regression, and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can all recollect, without any doubt or without any confusion, because I keep repeating it, so please bear with me, because that's basically to keep everybody motivated and in line with the course. So, there are three main topics which are under this umbrella of this course. The first one being averaging techniques and forecasting, the second one being regression models, and third one is time series analysis. And as you know, that we are covering the concept of averaging techniques and forecasting, and this is fourth week 20th lecture, which is the last lecture of the fourth week, because if you remember, each week there are 5 lectures of half an hour each. Now, in the last class we spent a lot of time in trying to understand very simply using Excel sheet the Holt linear method and the concepts of what is alpha. Alpha is not the weights for forecasting. Remember, for all the other models, whether it was moving average, whether it was single parameter non-adaptive exponential smoothing, single parameter adaptive exponential smoothing, multi-parameter non-adaptive exponential smoothing, then multi-parameter adaptive exponential smoothing. So, in all these, alpha was the weights. Some of the alpha weights was 1. There was concept of beta also, which was brought into the picture for adaptive single parameter, adaptive multi parameter, which was basically the weights for the errors, and also the concept of some of the weights for either for betas taken together or for alphas taken together was always 1. Now, here in smoothing concept is being utilized, trend concept is being utilized, a starting level value is being utilized. Hence, based on that fact, we will basically have an idea of alpha which is being utilized, where it gives weightages both on the level and the trend. Remember another thing, that the level is given by L and trend is given by B with the corresponding suffix obviously, and M is the number of time periods ahead you want to forecast. For simplicity, we have taken M as 1, and we are doing that problem and will continue, not start afresh the new topic of Holt winter method, both the concept of additive and multiplicative model, because that will take time. So, I will try to devote that for the 5th week starting the 21st lecture. So, 20th lecture would be different ways of how you try to draw the graph. So, now the starting values concept we have already discussed. I will just mention, if you remember, I had taken, and this is a repetition, please do not mind, we are taking the value of level L1 is equal to the actual value of Y1 as it should be, as intuitive, because in the same way, like the forecast of today is being best predicted by the actual value for one day before. One day, why I am using the word one day? Because I am considering t minus 1, t minus 2, or t plus 1, t plus 2. So, if t is today, so one period, I should use the word one period, one step forward or one step backward. So, here y1 is equal to L1, that is the level for January is equal to y for January, which was 1 for 43, and the trend is basically 152 minus 143, which is basically y2 minus y1 actually divided by 1, because this is 1 month. So, I could have also taken, if it was smooth, I could have also taken y3 minus y2 divided by 2. So, here again I am drawing, please excuse me, because I have done it in details in the last class. I will start again. So, the recap happens, and any confusion you may have had in the last class with the diagrams being drawn, it will be removed, because this being more of a one way flow traffic of communication from the instructor to the students. So, any interaction which you would have is only through the TAs and later on. So, I may go slow in some of the points, I may repeat it time and again, but that just for double and triple clarification. So, to remove any ambiguity, remove any amount of confusion. So, if I utilize the x and y axis as, so consider this is the x axis time, this is the y axis for the values, and you have that. So, I will draw the time frames as dotted lines. Time frames means t minus 1, t plus 1, t plus 2, so on and so forth. So, this is for the time. I am using my level best of drawing, so that the scaling system is not disturbed. I have tried my level best. So, consider this is t, this is t plus 1, t plus 2, and it continues on to the right. So, left to t is t minus 1, t minus 2, and continues to the left. So, if I consider, I will take only one data set, not 3 different colors. I'll come back to. So, if I consider, I am starting here. So, if this is the level I use the black color. This is the level when I am starting. So, actually what is L1 is basically the actual value of y1. So, this red line is basically the y values, and if I extend it backward, let me do it for. So, this is one trend, and I will draw it with a different color for the different line. So, here the value of B1 which I am taking can be calculated like this. This can be height by base. By base is 1, because you remembered it is time period t minus of t minus 1, which is 1, and this value which you have is basically 152 minus 143. That was being utilized. Now, in sense, if it was, I need to find out B1, but what if I take 2 time periods? If it is not a very huge fluctuating one. So, I will erase this 1 time period. So, what was the data? Let me check. So, the values, if they are entered and when you go back to the Excel sheet, so it will be absolutely crystal clear. I will just go back. This second value was 161. So, you go back here. So, the data was the 161. So, it is 2 time periods. This is t plus 1 minus t minus 1. So, plus 1 becomes 2. This is 2 time period, and the height would be actually 161 minus 153, 2. Now, the value is about 161 minus 152 is about 10, 10 by 2 is 5. So, here the value is 9. So, there is fluctuation, that is why I took 9. So, alpha is assumed, beta is assumed, m is assumed, m is 1 if you remember. Beta can be taken in the range, if you remember, 0 to 1, alpha can be in the range of 0 to 1. We have already done it. So, let me go back to the Excel sheet. So, this is the data which I had. Now, this Excel sheet you have already seen. So, now I need to do is as follows. I will draw another curve with different values, and let me do it here for CS. I will draw the curve here. So, what I am doing is this. I will take combinations of alpha and beta. So, alpha as let me check if I can use the symbol of alpha. Do I have the symbol of alpha somewhere? Yes, yes. So alpha here. I'll copy it into text file. Oh, it's not copying. Can I copy? Let me continue with writing alpha. Alpha 0.2 and beta 0. Say for example 2. Let me consider. And there I next value would be alpha 0.2, beta 0.4. So I am keeping alpha fixed, changing betas. So next value is alpha 0.2, beta 0.6 and alpha 0.2, beta 0.8. So now basically I will keep changing alpha. So let me copy the values. So in this cell it is beta is still 0.2 but alpha is now 0.4. Next one is basically beta is 0.4 and alpha is 0.4. Alpha is now fixed at 0.4. Next value is beta 0.6 and alpha 0.4. Then you have beta 0.8, alpha is 0.4. So I have alpha 6 at 0.2, beta 0.2, 0.4, 0.6, 0.8. Then alpha fixed at 0.4, beta is equal to 0.2, 0.4, 0.6, 0.8. Let me take another set of combination which are as follows. It is now beta 0.2, now alpha is increased to 0.6. So alpha remains as 0.6 and then I change beta as 0.2, 0.4, 0.6, 0.8. And finally, I want to do is now increase to the last level of alpha which is 0.8. So 0.8 alpha being fixed, beta will change from 0.2, then 0.4, 0.6, 0.8. Then I change alpha to 0.8. Okay, next alpha changes to 0.8 and finally alpha to 0.8. Now I have all the different combinations of alpha beta and what I need to plot out are these. Okay, I need to remove it because there are some other data. Let me go. I'll go to the right because there are a lot of data in this, lot of calculations. So once you check, you will understand. Let me do it here. Let me do it in the sheet 2. This will be easy. Sheet 3. Perfect. And if I have, what I need is these. Yes, these 3. I have here. Now I'll keep making and copying this value. It is slow method, but please bear with me. So I am going to combination of alpha 0.2 and change beta point, then 0.2, then 0.4, then 0.6, then 0.8. So let us do alpha is 0.2, beta should be 0.2. Perfect. These are the values. I'll copy paste the values, not the formulas. So if I go here, I copy paste the values. So now I come to beta 0.4. These are the values. I copy the values only. Then I have beta 0.6. I copy the values. Copy the values means mean absolute error, square of the mean squared error, and the mean error. Pasted. Then I have the values of alpha 0.8. The values are given here, paste. Now let us check for the time being for these 4 combinations, how they look like. So if I have, now see here, I can have the heights also, because the histogram will give me much better reading. Yes. So you make it all as, see for example, not gray, I would have it the green one. No, wait, I should, the filling up would be there. Yes, filling up should be green. Done. Filling up should be green, filling up should be green, and finally filling up should be green. Done. So if you see, and let me make it red. So red, blue, green would make a good way of trying to see the picture. So done. And let me make it as dark blue. So this is standard. I go to here, dark blue. Done. So I have, so alpha 0.2, beta 0.2, alpha 0.2, beta 0.4, alpha 0.2, beta 0.6, alpha 0.2, beta 0.8. So if you see for these 4 combinations, you will get a good idea how the metric values are with changing values of alpha and beta. So with this, let me continue, and continue in the sense, now I change the value of, so I have done 0.2, 0.2, 0.2, 0.4, 0.2, 0.6, 0.2, 0.8. So now I need to basically do for alpha 0.4, then beta being 0.2, 0.6, 0.2, 0.4, 0.6, 0.8. Let me check I have written it down correctly. So I don't want to commit any error. Done. And then alpha 0.6, done. I have written down. So I need to basically put the values accordingly. Perfect. So I will now put the values of alpha 0.4 and beta changing. So alpha I change 0.4. Done. So now is basically beta is 0.2. Done the calculation. So I copy these values directly in F column. Then I go to beta changing to 0.4, values copied, then pasted in column G. Then beta changed to 0.6, values copied, pasted in column H. Now beta 0.8, last value in the set when beta is alpha is 0.64, copied, pasted, done. Now I go alpha one level higher, 0.6. So, for 0.6, beta 0.2, I have the values. I am not reading the values, I am just copying it. If you can, I am not copy pasting, copying the values only. Then I go to beta 0.4, then I go to beta 0.6, values copied, pasted. Then I go to 0.6 of 8. 0.6 of 8, 8 means 0.8 of beta. Values copied, pasted, done. Then I increase alpha to 0.8. Beta again 0.2, values copied, pasted. Then I do it for beta 0.4, alpha is 0.8, remember, copied, pasted. Then beta 0.6, copied, pasted. Finally, for 0.8 alpha, 0.8 beta, values copied, pasted. Now, if I want to plot all the values, so let me check the graph. So, this is an interesting graph. Interesting in the sense, so chart title, so first I will mark these colors. So, there is specific colors of red, green and dark blue is used, and along the x axis you have the different combinations of alpha and beta, starting from alpha 0.2 to beta 0.2 and to last value of alpha 0.8 beta 0.8. See how these values change. Now, one thing is very interesting. For values of alpha very low and beta very low, the mean absolute error and the mean error are almost the same. So, as you can see here from the graph. So, obviously, there will be decimal values difference, but I am not going to that. Number one. Number two is that the mean error slowly decreases, and the difference between the mean error and MAE and square root of MSSE, which is mean squared error, square root of that is standard deviation sort of thing. That difference between the red, green and the blue increases as you increase alpha and beta. Now, alpha, beta increasing and decreasing I have already explained with the diagram. Now, if I basically do a plot of this, of the data set, so I can change it to say for example, scatter plot. So, the scatter plot would look like this, but the line diagram is giving us much better information. So, this is the line diagram. Now, the question can be, I have only done MAE, ME and square root of MSSE. Can I do it for the U statistic? Yes. For the percentage error? Yes. For the absolute percentage error? Yes. For the weighted, no sorry, weighted absolute, weighted percentage error, my mistake, weighted percentage error? Yes. For the weighted absolute error? Yes. Weighted mean error? Yes. So, depending on what weights you want to apply, whether you want to penalize more, penalize less the errors, you can basically give the weights and draw it. The weights are basically for the errors. So, the conceptually the idea of the weights for the errors would be in the same way as the ideas for alphas which you have, where the sum should be 1. Now, with this I will go back to the slide. So, you have the data starting from January to the months given, January, February, it goes to December, again January to December, 24 months, because you remember what you have done. Now, here are some very simple plots. I have done in Excel sheet details, I am just giving a snapshot. So, for alpha 0.2, beta 0.9, M1, M is always fixed as 1. I plot the values of actual values of y, the L value and the F value. If you remember, y is actual value, F is forecasted value and L is the level. Now, if you see for values of alpha low, beta high, we have already seen F becomes almost a trend line and the L value is superimposed here. If you see here in the diagram, the orange and the yellows are almost superimposing because the level is increasing as y fluctuates. So, that can be differentiated if we change the values of alpha and beta accordingly. Now, I do for the errors. So, the errors for and B, I am doing both. B is basically the average trend, even though drawing them in the same graph may not make sense, but I am still trying to do that. The errors part green which you have already seen, the errors were fluctuating. But what is interesting is the trend which you see, which is B, is almost becoming 0 for values of alpha 0.2 and 0.8, which means the trend is basically not increasing. Here I do it for different sets, alpha 0.6, beta 0.1, and here now you can differentiate. F is no more, F is the forecasted value, is not a simple line, because the weightages which you are giving would basically have an effect. Now, practically how you utilize would depend on the problem which you are solving. So, I am just giving you different scenarios, again Y, L, F for and M is equal to 1. Here also, now very interestingly, the trend fluctuates, then slowly becomes almost 0, and here the errors are being plotted for different values as given alpha 0.6 and beta 0.1. Now, this is an example for to basically give. If you remember, I mentioned U statistics also. So, there here for M1, so in the topmost row you have M, alpha, beta. M is always 1. Beta, alpha, beta are taken in the combinations of 0.6, 0.1, 0.7, 0.1, 0.4, 0.9, 0.1, 0.01, 0.2 and 0.90. I mark for this, you can use the Excel sheet, the mean absolute error, the mean squared error, the U statistics, and if you see the blue line, blue highlighted values are for that corresponding combination of alpha and M, alpha and beta, because M is 1, where you get the best result, in the sense least. And here very interestingly, the value of 0.6 and 0.1. Obviously, I can do much more simulation to find out which is the best result. With this, I will end the 20th lecture, which is the last lecture of 4th week, and continue discussing more about the other forecasting techniques, which would now be Holt winter method, considering both seasonality as we in the concept of additive as well as multiplicative. Thank you very much and have a nice day.